All right, now we're going to do 29.2, construction of parallel and perpendicular lines. Very important for a lot of different things. So first, we're going to construct a parallel line. We want a line that's parallel to L, but goes through H. I think this is very difficult. I don't think mine's going to look very good, quite honestly. So first thing we need to do is we need to draw a point on line L. Label it I. Now we need to make an arc, radius of IH, to intersect line L, to call it J. So again, do the best you can. It's difficult. As I keep dropping my compass, it just shows how difficult it is. So see the radius there. Call this point J. And now we want to use radius of HJ, so that segment, or that distance, and draw arcs from H and J and label their intersection K. Again, I think this is the most difficult part. Mine never ends up looking all that great. So find the distance the best you can. So out here, and then one out here. Again, it's tough. So the point of intersection, okay, and kind of cheating a little bit, and then we connect it, and we have parallel lines. Mine's a little bit off, but again, as long as I see the right arcs, I know you did the right process. They're parallel. So HK is parallel to IJ. Not perfect. All right. Now, we're going to construct perpendicular lines. So not necessarily a perpendicular bisector, although kind of we are, but we have to get the same distance on either side for O. So using whatever radius you want, draw an arc on this side. Using the same radius, draw an arc on the other side. So we can label those L and M. And now we're going to do perpendicular bisector like we did before. So we go from L, make sure it's more than halfway, and it is. And using the same radius, do the same thing from M. And then we'll label those Q and R. And when we connect those, it's perpendicular and it's through O. It's also a bisector of these, but that's not really what we're looking for. We were just trying to make sure that QR is perpendicular to LM. So very similar, but first we had to find these points. So similar to our perpendicular bisector, but we had an extra step. All right. If we're looking at constructing a right triangle. So really, same thing. We need to get points on either side of H that are the same distance away. So I'm going to use this. And this. I'm going to label them P and Q. And I'm going to make a perpendicular bisector from there. Again, just like what we just did. Of course, you got to make sure your paper's steady, and as steady as you can. Do the same thing from Q. But now instead of connecting all the way through, because we don't need that, we just want from one of those points, I'm going to use the top one, connect it to H. I'll call it that top point W. And I know this is the right angle, so I just got to finish it off. I'm going to connect WQ, and I have a right triangle. So again, very similar to our perpendicular bisector, but, and just like making a right angle, we just have to close it off and make a right triangle. Then Pythagorean theorem works and all that good stuff. All right. Construct a perpendicular bisector in a triangle. So perpendicular bisectors, same thing. So that's really what all this stuff is about. So do those same steps that we did before. So an arc above and below segment BC, do the same thing from A. And if you use the same radius for all of them, it's a little bit easy. You don't have to switch a whole lot. Up, if you notice, I didn't get this to go all the way through, so I need to make sure that I go back, and really you should make sure that your arcs go as far as you can. Not necessarily a whole circle, but the more you do, the more there's a chance of things intersecting, and that's what we're looking for. So I connect these 2 points to get a perpendicular bisector here. Doesn't quite go to the vertex A. We do same thing for this segment. Again, I'm just going to connect it in the triangle. And we learned this before, but this one all should intersect at the same place if we did it right, because these 3 points should be concurrent. We did this first semester. That point, we'll call that D, is the circumcenter. And remember, the point of a concurrency is the circumcenter, and the center of the circle that can be circumscribed about the triangle. So this would be a center, and I could use that to draw a circle so it just touches B, C, and A and just fits in there perfectly. And that's what we have for 29.2.